Hi, in this video, we are going to use KNN or K-nearest neighbor as another supervised learning approach for classification. Our data sets are Learning Club test data and training data that I will upload them into the files in Google Cloud. Remember that we always need to upload files if they are in the Excel or other formats to this area. And then we call them or upload them in our environment to start working with them. So before going through, we need to call required libraries, same as usual. Import numpy as np, import pandas as pd. Also, matplotlib die.pyplot as plt. And the required packages for KNN also would be called. The package that we are going to use here is from sklearn, which is one of the most famous libraries related to machine learning. We are going to use neighbor. So sklearn.neighbors import k neighbors classifier. So the function is k neighbors classifier, which is located in the sublibrary neighbors, which is located in sklearn package. Also, we are going to import some matrices from the same package, sklearn. So accuracy score, for example, and let's say recall score, for example, F1 score, precision, score. We can extend the metrics to ROC curve, AUC, average, precision score, confusion matrix, classification report, ROC AUC score. These are common scores or measures that we can always download them and or call them to be used for classification purposes. The next step is to upload our training sample. Our training sample is located in Learning Club train data. So I'm going to use pandas package function read Excel. And you need to give the path. So the path is here. So copy path and put it there. And the test one, which is PD, read underline Excel. Do the same. Copy path, and we put it there. And if you print it, print train.head, you will see we have got information about our training sample. Let's have a look at the first 5 rows. So we have got basically 5 um, variables here: home ownership, income, DTI, FICO, and loan status. So loan status is our target variable 0, 1. The other 4 are the features that we are going to use. Home ownership is a binary variable equal to 1 if the actually loan applicant is homeowner, otherwise 0. Income is the income level, DTI is the debt to income ratio, and FICO is the credit score of the applicant. So we have got this information. Also, you can have a look at the train set or test set to have the same sort of information there. So as you see, the information provided in both training and test set are the same, basically in terms of variables. But what we need to do is to have our X train. So we need to split a training sample into X train and Y train. X contains just features, which are home ownership, income, DTI, and FICO. Remember, if you want to select more than one column, you have to put 2 bracket squares. All right. And Y train would be just loan status. Okay, so we have got X train, Y train, the same for the X test. We can do the same. So for saving time, I'm going just to put it there. All right, so we would have X train, Y train, X test, and Y test. And the next step is to basically normalize the variables. It's very important for some classification or machine learning techniques to do normalization. So I'm going to normalize the variables X train minus their average dot mean over X train dot STD, standard deviation of each variable. And the same for X test. We are going to do the same equation for X test as well. So I'm just going to replicate it, and we should have X train and X test. Now, if I print them, you will see that the variables, sorry, X train, X line train. So if you look at the variables now, see they are normalized, which means that they're rescaled. So we don't need to be worried about different scales of explanatory variables or features. Okay. So now it looks that we are ready to basically develop our classifier, KNN, and see that how this classifier could perform in predicting basically a default. Before going through, also we can have some graphs explaining the relation between these variables. For example, I can use PLT to show the relation between income and PLT Y label FICO, for example. So I want to see these two variables, how these two variables move together. So PLT scatter. So in the X train, so basically my X would be income, and the Y would be FICO, And let's change the color to, for example, red. And marker would be, for example, plus. Okay, so let's run this code, see what we have got here. So we have got X label. I've got an issue here. Yes, X label, so misspelling. Y label, FICO. Well, this time is going to work. Yes, so we have got the relation between income and FICO, as you see. Lower income is not necessarily related to FICO. Um, Meanwhile, we can have the same for our test sample to see if they are consistent or not. I mean, our test sample and basically training sample are consistent in terms of the relation between income and FICO. And as you see, they're consistent. So the red one are the training sample and blue one are test sample. Okay, so now we are going to create our KNN model. As you might know, in the KNN, we are going to determine the number of neighbors to any observation to be classified according to closeness to the attributes of those neighbors. So we can start with, for example, K2 and K5. And we are going to develop our KNN model using the function K neighbors classifier. And the number of neighbors is equal to K. Simple model. We're not going to make it complicated for now. And then we are asking Python to fit the model, considering our X train and Y train. So always we develop model or fit model using available information, which are training sample. And we are going to predict it. The next step, Y pred would be equal to KNN dot predict using now X test. So we want to predict Y's considering the new information from our test sample using the model which is fit based on training sample. All right, so what is in the Y pred? The Y pred would be basically, sorry, misspelling. The Y pred, it would be an array of 1 and 0 basically. So our model predicted if the observations or clients basically in our test sample are going to be classified as 1 or 0, good customers or bad customers, right? Okay, so let's plot our confusion matrix in the first step and explain it briefly, what's going on here. Plot. I think I already called for confusion matrix, so I have it here, so I don't need to call it again. So let's say CM or confusion matrix is basically confusion matrix using what? Y test. This is the actual test in our sample versus the predicted one. What model predicted? So there are actual observation test sample versus the predicted by the model. And if you call them, so we would have our confusion matrix. So confusion matrix suggests what? The first one is the number of basically zeros which are predicted as 0. This one is the number of zeros which are predicted as 1. This is the number of ones which are predicted as 0, and this is the number of ones which are predicted as 1. Okay, so these 261 observations have been 0, correctly predicted as 0. 1691 observations have been 1, they are correctly predicted as 1. Okay, so this is what meant by confusion matrix. So to have a better illustration of confusion matrix, we can use again another kind of graphing. This time we are going to use package Seaborn, which is used again for graphing and basically having plots in Python. So Seaborn has SN, so I'm going to first of all say, okay, PLT is going to be the size is going to be, for example, let's say 10 times 7. So here we decide about the size of our figure, and then using DSN, I'm going to create heat map and put the CM there and ask to have some annotation. And the format of those numbers should be, for example, 1 decimal. And again, PLT, our PLT, we have got X label. X label is predicted. Make it, we can predict it. And Y label would be the true one or actual one. And this one is a misspeaking error. Okay, true. And that's, let's run this code. PLT figure, big size. So yes, PLT figure, big size 10.7. We have got an issue here. Must be an iterable, not float. Yes, I'm sorry. Should put a comma here. I did it by mistake. Yes, so we have got a figure now. So the CM matrix here changed to a figure. And as you see, the actual value is 0, predicted as 0, 61, actual value 1, predicted as 1 is 1691. If I change anode to false, you don't have this explanation on the graph anymore or in the plot anymore. That's what anode does here. And if I change this one to 2, so you would have 2 decimals. Okay, so this is just the explanation what each of these items or arguments do in coding. So as you see, it's very flexible. Now we have got a heat map, so we could plot a heat map here. This is the total number of observation over sample, almost 1600, and the way they are classified, almost maybe 1700, and the way they are classified into different groups. Okay. And now the next step is to have basically area under rock curve. For area under rock curve, we need the probability. So that's why we are going to use the function predict proba. And again, the same, we are going to apply X test. This time, we would have a function. If I run this one, you will see that we have got an array consisting of 2 columns, or we have got a 2 array matrices, all right? The first one is the probability of being 0, and the second one is the probability of being 1. Okay, so for each observation in our sample, we have got probability of being 0, probability of being 1, okay? And the point here is that we just need one of these 2 probabilities to be used for our purposes, which is drawing a rock curve, okay? So we usually choose the probability equal to 1, I mean the second column, to be used for our purpose. Okay, so uh, let me go to the next step and uh, trying to draw the rock curve, area under rock curve. So there are some steps I'm trying to explain for you step by step. Again, PLT is um, the function that we uploaded actually to our environment. Is stands for matplot lib.py plot. It's used for plotting, and fixed size is a function to determine the size of the our figure. So PLT figure fixed size, we can determine the size of our um, plots. And then we have got plt.plot. What we are going to plot here, we need FPR, false positive rate, true positive rate. And for this purpose, in the first step, we need to calculate this false positive rate and true positive rates. Okay. So let's say the color would be dark orange, and the marker is going to be, like, for example, simply dots. There are other characteristics. For example, we can say the size of the plot and label of the plot, right? Label would be, like, say, KNN. So AUC of the KNN would be equal to 0.4 F. So I want ask Python to present the KNN calculated area under rock curve for this model in 4 decimal and put it there, and attach it to the value rock AUC, which should be calculated. So we need this value. So I'm going to calculate these values, FPR, TPR, and rock curve. As you see, they're underlined now because they are not estimated yet. How we can estimate them? We have got a function for FPR and TPR, which is rock, basically rock curve. Rock curve function would be used for this purpose, and we need to put y test and q. Okay, y test and q, or the probability here. Okay, so so the rock curve, as I said, should be used, and we need to put the probabilities basically for the estimating false positive rate and true positive rate. We need to put the uh, basically the probabilities which are estimated before, all right, versus the actual value. So we have got y test, and we need the q, or the probability. Again, q should be estimated. And what is the q? Q is basically what we already estimated here. All right, KNN predict. But remember, we just need one of these two estimated probabilities, and we usually pick up the second one, the probability of being equal to 1. So that's why we put column, comma, 1. I'm asking Python to pick up this array. All right. So column means that all rows should be selected. Comma 1 means that the second column should be selected. You know, Python counts from 0. So 0 means column 1 and 1 means column 2. So as such, we are going to select this column of probabilities and call it Q. So we are putting this Q's estimated Q versus the actual ones, and we estimate FPR or false positive rate, true positive rate. Okay, and the underline refers to the cutoff point. We are not interested in cutoff point. We are not going to name them anything. So the point here is that this ROC curve function generates 3 arrays: false positive rate, true positive rate, and cutoff points. We are not interested in cutoff points, so that's why we put underline. And we can run this one. So we have got now FPR and basically true positive rate as well. And one more thing we are interested and we are looking for is the ROC AUC. ROC AUC also need to be calculated. So you can say ROC AUC is equal to AUC, the function we already called at the beginning of this script. And we are asking Python to calculate AUC, area under ROC curve, considering FPR and TPR. So let's see what we have got. We have got Q, let's call it. So the Q is just one array. As you see, this is a probability of being equal to 1. These numbers, right? And we have got FPR, false positive rate. Again, an array, false positive rate for different cutoff points. The same for TPR, true positive rate for different cutoff points. And we have got ROC AUC, area under ROC curve, for this model, which is 58%, okay? So we have got this information. We're going to apply this information in the next step in a figure, okay? So we call them area under ROC curve figure. And so estimated area under ROC curve using our model is going to be plot against a random model. So for random model, X is between 0 and 1, and Y is also between 0 and 1. The color would be, for example, let's say blue. And the length would be, for example, 2 as well. And the, let's say, line style, we can have a line style here. We put it, for example, dash dash, and we're gonna label it. We call it random prediction. And the area under ROC curve for random prediction is always 0.5. So we don't need to go for its calculation. All of them should be in quote because they are string numbers. So random prediction label, and I think everything is there. And then go for some more details. For example, the X limitation, X-axis limitation from, let's say, 0 to 1, and the same for PLT Y limitation, which is between the same, can say between 0 and 1. So we are deciding about limitation of each axis to be presented or shown in our graph, and PLT X label, which is true positive rate and PLT Y label, which is false. Sorry, X label should be false positive rate, and this one should be true positive rate. And we have got the title of our graph again. So we have got a function title. So we call it AUC, or area under rock curve. And finally PLT, like let's say legend. We can even determine the location of our legend. We say, for example, upper left. And finally, we ask Python to show it, PLT show. And let's run. Hopefully everything would be fine here. Okay, so we have got area under rock curve. Our curve is 0.5 for the random model and 0.58 for our developed KNN model. So here, as you see, there is to have a better presentation, we can change the X limit to, for example, 0.05 and Y level. And in this case, we are going to have a better presentation as well. So yes, this is how we can end up with the KNN. As you see, we have got a KNN model. So let's increase the number of Ks to 25, for example. And let's see what would be the new model. And so the confusion matrix, its map would be changed, and prediction, estimating Q, false positive, true positive rate. And this time, see, 0.63, the model improved. Okay, the question here is that how we can find out the optimal K to be used. One of the benchmarks we can use is basically minimum error. So our goal here is to reduce minimum error. So I'm going to explain the codes to save time here. So here we are going to create an error rate array. So here we put error rate is equal to open close bracket. So this is suggests that we are initializing an empty list called error rate, and then this list is gonna be filled by estimated error rates. Okay, using different Ks. We are going to try a range of K in our KNN models. From 1 to 40, you can extend it to 50 or 60, whatever you like, but it depends on the number of observations we have got. So basically anywhere in Python, we say for I in range of numbers, for example, 1 to 100, it suggests that we are going to do a loop or iteration process. So we're going to develop KNN, K neighbors classifier. N neighbors is equal to I. So I is going to start from 1, okay, and do this process. So the Python starts from I equal to 1. It first put neighbors, N neighbors equal to 1 here, and fit the model and predict based on the fitted model, and append the error rate to this error rate list. So it estimates basically error rates. It calculates the error rate for the current value of K, which is 1 in the first iteration, or the first round of running the model, by comparing predicted labels with the actual ones. So if they are not the same, it takes them as error and estimate the average of those errors and put them there. Then Python starts from the second I, which is 2, and do the same procedure and add it to error rate. Then after 40 times repetition or iteration, it stops, okay, and start doing the same, continue of the code. So start from here, 40 times this code would be repeated. Once the number 40 is hit, it's going to stop and go to the next line, which is PLT figure size. Now it's going to plot for us what we have got range of 1 to 40 as X and error rate as Y. So others are the characteristics of our plotting. Color is going to be blue, line style dashed, marker, for example. This one, all of them are customizable, changeable. The title would be error rate versus K value, and the label and show. Finally, we can say, okay, if you run this code, we have got the graph. Yeah, error rate versus K value. So as you see, for different values of K, from 1 to 40, we have got error rates. Lower error rate is our um, uh, object. So that's why we need to find out a K which ends up with the lower uh, error rate. From the shape, we can see that it should be somewhere between 25, 26. So we can check it out here in that way. So we can ask Python to print what? Minimum error. This is a string. From what? So minimum error would be the minimum number in our error list. Remember, our error list now should have 40 error rates, yeah, considering different cases. So find out the minimum number and attached it or assign it to the K which caused that minimum error rate. So at K error rate index. So Python start counting from 0, 0, 1, 2, 3, 4, and it find out the assign the index where the minimum error rate is located. So it calculates that index and put it here for you. So as such, you have got minimum error rate 0.256 at K equal to 26. So the point here is that we can back to our model and change this K to 26. In that case, we would have a better classification, okay? Considering error rates. We can also use this approach if our criteria is to find out basically models based on other criteria. So you can do modify this code in a way to, for example, minimize type 1 error, or minimize type 2 error, or minimize overclassification. So it's up to practitioner which criteria matters most for them. So this is the way that we can use KNN in classification. Hope you enjoyed this tutorial, and please let me know if you have got any questions. Thank you very much.